My name's Cameron Dumas.
I'm Noah Dupree.
How did we come up with the project? First of all, we were thinking of a concept of how kids with CP can be able to throw and catch balls just like we would with our limbs. So we were thinking, what's the best way for them to articulate a motion of throwing a ball or any object that they want to? And that's how we came up with the Geaux Throw.
So our inspiration for the project was after going to McMains, we noticed that a lot of the toys they had were geared for younger kids. And as me and Cameron being teenagers, we don't like playing with little kid toys, so we wanted to think of something that would be fun for the older kids to interact with as well. So I know a lot of people can go back to thinking of playing catch with their dad in the front yard, so that's the thing we thought of, how we could get them interacting with other people and having fun at the same time doing something that older kids would do.
What sort of challenges we faced over the course of our project? There were a multitude of challenges. One being changing our mechanical structure at least 3 or 4 times. We had to collaborate and think of different types of systems that would work for them and be easier for them to operate. And the second challenges that we mainly faced were electrical. The button is not the easiest thing to work with, so we really had to get around that with the wiring and such.
So the way we overcame these challenges was just through trial and error, just doing different things that we thought would work and then finding out that they didn't work, and then ultimately just settling with the best solution for the children.
Our overall NuVu experience was incredible. First off, I'd like to thank NuVu and Episcopal for giving us this opportunity to be able to work with all these great materials as you see around. It was a one-of-a-kind experience. It takes you out of the normal classroom setting where you're sitting down with a textbook and you're able to use your hands and be hands-on, and it's just amazing.
So for me, my NuVu experience was awesome. Just like Cam said, I like how you're not really sitting down taking notes, listening to lectures. You get to actually interact with these different tools and do a lot more hands-on learning, which I find is easier to learn from in certain ways. So if you look right here, this is kind of the center of attention. This is what makes the whole thing work. So it's based off of a choo-choo gear or motor. So essentially what happens is this part will come down and the gear will turn with it. And then it goes all the way around and then straight back up. So with this gear and motor, we thought it might be kind of dangerous that kids could get their fingers caught in it and it would cause some serious damage. But at the same time, we didn't want to enclose it completely because we thought that this was like the coolest part of the project, so we really still wanted to display it. So we just decided to cut polycarb and just set it around so you can still kind of see what's going on, but at the same time you're not really able to get your hands inside of the motor as easily.
Okay, back to the electrical part. As we said, we came with a various amount of ideas. We thought of switches, we thought of actual handles that you'd be able to crank the choo-choo with, but we knew that they wouldn't be able to have the range of mobility with their arms, so we came up with the button system. This system, it's pretty simple. I sort of designed it myself. I took a 12-volt battery pack and a simple button, and I soldered the wires to the button to the inside of this motor, and this motor runs from the battery to the button, and there's a disconnection inside the battery pack, and it'll stop the connection when you're not pressing the button. So once you press the button, and that's what makes everything work. It seems sort of simple that you just plug a whole bunch of wires in and everything will work together, but it's actually a lot more difficult than you think. Soldering and putting the wires together, it's very tedious. You have to be very meticulous and make sure you have all the wires and the connections together so it can actually work, because the slightest misconnection or the wrong cross wiring, everything can go bad. So
this is our button. So the way this would work is you would attach it to the child's wheelchair, just like this. And this just makes it easier for them to actually use the machine. So it's a little bit closer. They don't have to use their hands that much. They can just simply tap the button and it'll work. So what they would do is they'd press the button,